Good evening, everyone. Fluid mechanics. We want to review an interesting problem in the water momentum. So, in this example, a 20 millimeter diameter stream of water with a velocity of 8 meter per second just comes out from the nozzle and then collide with a blade, a curved plate, and then deflected by an angle of 120. If the blade itself is moving to the right, we want to calculate the force F from the blade to the water. So we are going to calculate the force of F from the blade to the stream. So let's consider the geometry of the problem. So there is a stream flow coming out of the nozzle from a 20 millimeter nozzle by the speed of 8 meter per second and then collide with a moving blade which itself moves to the right at the direction of the flow and then deflect by an angle of alpha which is 120 degrees. R is represent by the force of a stream or water to the blade, and the opposite force due to reaction, it just comes from the blade to the water, and we are going to calculate the reaction, the force of the blade to the water, which is exactly the reaction of water to the blade. So in applied force to the curved plate, we have like, if we just consider x and y direction, Rx due to momentum is rho density times q discharge times v of j, which is the outcoming flow velocity, times in parentheses 1 minus cosine of alpha. And r at y direction is rho qj vj sine of alpha. So, and then resultant definitely is a square root of rx squared plus ry squared. Then the reaction from the blade to the stream is exactly the same like reaction, but in the opposite direction, as you can see down here in the figure. If you replace just qj discharge by area times velocity of j, and then also be careful to use the relative velocity due to both of them blades and the water has the speed at the same direction. So definitely the relative velocity, my bad, you have to subtract that. That's 8 minus 3, that's 5 meter per second. Then fx is rho a uj squared, the relative velocity replaced in the main equation, 1 minus cosine of 120, which is provided in the problem statement. If you do the math, it just gives you Fx is equal to 11.78 newtons. And likewise for Fy, that's rho AUJ squared sine of 60 or sine of 120. The sine of 60 and 120 is exactly the same. You can use either of these two in terms of Fy for sine of 60 or sine of 120. If you do the math, that's give you 6.8, and definitely the resultant force is equal to F sub r is a square root of fx squared plus fy squared. And if you do the math, it just gives you resultant force from the blade, curved plate to the water jet is 13.60 newtons. Thank you. We'll solve more problems.